So this is your maths memory card, which should serve you throughout this topic. So let's get this out and let's make a list of all these key things we need to put on here. If you haven't got one, duplicate one please in your own way with the same structure and design of this. So the topic definitely needs to be put somewhere on this card, which you can highlight over here, Advanced Formulae. The grades are 6/7, so they can be quite challenging. The two key points within this topic we're going to be learning are factorizing and fractions, which come up in different ways, which definitely will be throughout this topic. So just be aware of this. Example is obviously for you to write any kind of question you might find useful in this video, and the steps for any 3 key points you may want to put through this that help you. Let's turn over and let's subsection this into our toolkit. So on toolkit you should have 3 clear subsections, A, B and C. So write these down, because as we go through the video we'll simply jot these down to give you a clear understanding of the key areas you need to learn. Let's start with back to basics. Question 1, back to basics. Press pause, rearrange to make X a subject, and press play when you're done. So this is a very basic question, you may realize, and remember from before, this is called double swap. So first of all, let's get all the X's on one side and the numbers on the right. So all the X's we're going to put over here. We want to shift them to the left, and let's call these the green boxes, which we're so used to by now. All the X terms, the green boxes, and all the non-X terms, we're going to call the red boxes over here. Okay, so we simply want all the greens on the left and the numbers on the right. So let's get this. Look each one in turn. 4x is good over here. The plus y will make a minus y over here. Z, we like it over here. The minus x, we're going to make a plus x over here. So we have the following: 4x plus x equals z minus y. Let's simplify each side. So 4x plus x, or 4x plus 1x, is 5x. 5x equals z minus y. One more step, x equals z minus y. The whole thing is going to be over that number, which is 5. Okay, so this forms the basics of a topic called factorizing. We're going to be doing later on today, but make sure you're okay with how we go about the main concept of double swap. X is on the left, numbers on the right. There we go. Question 2, back to basics. Press pause, write this question down, find an X, and press play when you're ready. So here we're making X a subject, and there are a couple of ways we can do this. Let's have a look at this first method over here. Okay, either way is correct. So any kind of X, we're going to call this with a green box over here, and any red over here like this, so pi and y. So golden rule, X is on the left, numbers on the right. Let's do a few equal signs over here. So minus 2x equals this pi. That's got to come over here to make a minus pi, because there's a plus pi here, so y minus pi. So x would simply be y minus pi all over minus 2. Okay, so that would be a simple answer for this. Now another way of doing this, you could say it could look like this as well. Okay, so this is number 2. They're both the same. Sometimes you may want to get a positive x to start off with, so you may want to simply just do this. Let's write the question. Pi minus 2x equals y. So I would be inclined to do this. So pi minus y equals 2x. I've simply put this x to the right hand side over here. So this minus 2x I've shifted to the right hand side. If you look at all of these over here. Okay, so that's gone over here like that. Therefore, we could say pi minus y all over 2 would give us the final answer over here. And that's going to be x. Okay, so either one of those answers could be your final answer for this. Both the same thing. Question 3, back to basics. Press pause, rearrange this fraction to make x a subject, and press play when you are ready. So let's make x, or minus x rather, let's make this a subject over here. Okay, but how do we make this the subject over here, x? So first of all, we need to identify this looks like a fraction. And a fraction basically allows us to make two fractions, and any number or term can be represented with 1 underneath that. Okay, so an imaginary 1. This allows us to do cross multiplication. 2 times 1 equals 1 minus x in brackets times y. So therefore we could say 2 equals, or 2 times 1, let's do the full thing in fact, 2 times 1 equals y, 1 minus x. Look how we did this in terms of we put the y outside the bracket. Okay, so 2 equals y minus yx if we expanded the half problem. Let's just bring this minus yx to the other side now. If this makes sense, this is a x term. These are two non-x terms over here. So let's get the minus yx to make a positive one over here. So we have 2 plus yx equals y. So yx equals y minus 2 and x equals y minus 2 all over y. Okay, so a bit trickier than before, but again it does solve the purpose of this, of helping you to realize that we're going to be dealing with this when we deal with fractions and formulas mixed together. Question 1, call 1. Press pause, write this formula down, make x a subject, and press play when you are ready. So this question is all about making x a subject, and we're going to take a few things from basic formulae on this topic over here. So first of all, let's do the flipper. Now we want to do the flipper. Let's remind ourselves when the x is on the right hand side. So this is no maths involved. Whatever we see on the right, we simply write on the left. So square root of x cubed plus 1 all over 2 equals y. So this is just simply the flipper. Okay, we're used to that from basic formulae. Now let's look at the square root. We want to get rid of the square root, so we're going to square everything in sight. Okay, if you square everything on the left hand side, i.e. this fraction, you're simply left with everything you see inside that. Okay, so we have this equals y squared this time. Okay, now let's do a little trick over here. Let's put a 1 underneath this and let's cross multiply. Okay, so we can say this times this will equal this times this. Top left times bottom right equals bottom left times top right. So therefore x cubed plus 1 will equal 2y squared. We're nearly there. Now x cubed will equal 2y squared minus 1, and let's cube root everything. So x equals 2y squared minus 1, the whole thing over here, cube rooted. So go through these things. This is the most basic type of advanced formula, but it's quite easy once you understand this. Question 2a, core 2. So let's make x a subject again. Now on this we look for some familiar territory over here. Now this basically has 2 x terms within this formula over here. Okay, let's repeat, 2 x terms. That's how you can identify what we're going to do over here. So first of all, let's do this. Now when you see 2 x terms, we want to factorize this. Okay, factorize the left hand side. We'll take x out. Pi plus 4 equals y. Okay, so that's what you do. 2 terms mean you do this over here. Now very simple, this is imaginary times over here. If you put little times, you don't have to, only for now I'm putting it times, but this just simply means you have 2 separate in effect 2 separate, let's say, terms here. You have an x over here and you have, let's say, a non-x over here. This allows you to simply divide this. So we could do x equals y all over whatever we see, multiplying the x, which is a bracket, and it's pi plus 4. Okay, so fairly simple. This is called factorizing when you have 2 terms of x involved. So let's get our toolkit out and let's make these notes on section A. So if you write this down, factorizing, and write the example we just did, and this should obviously serve you well in terms of memorizing this key idea of having two terms in x on one side in particular, should we say, and making x a subject from there. Question 2b, core 2. Press pause, write this question down and make x a subject from this formula. So this question is very much like the one before. We're dealing with two x terms over here, except one's on the left of the equal sign and one is on the right. So in hindsight, let's think of this question backwards. You ideally want all the x's on one side, because if you have two x terms like this, but on one side, you could in fact factorize this. So let's do a technique called double swap you would have heard of before. Let's get all the x's on one side. Let's put them in fact as green boxes, just so you can identify these as clear x terms and non-x terms in the red boxes over here. So we'll shift this 5x first of all. This 5x is plus 5x, put a plus there if you want to, on the left hand side. Pi x minus 5x, and this minus y becomes a plus y, 2 plus y. This is very similar to double swap. Now we can actually factorize this. Take an x here and do pi minus 5 and equals 2 plus y. This allows us now to do the technique of well, simply dividing this, because we have an x term over here, a non-x term over here, and these are non-x terms too. So let's get only the greens on the left. So x equals, you've done this before, 2 plus y, and the whole thing will be over whatever is multiplying the x on the left, which happens to be pi minus 5. There we go. So the key thing was trying to get all the x's on one side before we factorize it, and the key thing was these two x terms in yellow. Question 3a challenge. So press pause, write this formula down, make x a subject, and press play when you have finished. So here we're dealing with a different type of formulae. We're dealing with a formulae initially involving fractions. Okay, so we can put an imaginary 1 underneath this first of all, because whenever you see let's say a fraction, let's put a 1 there, because this allows us to do cross multiplication. Okay, so we can put brackets around here. It's more helpful. They'll never put brackets, by the way. When you have two of these terms, it's always going to put brackets. So this times this will always equal this times this. Okay, it's a fact. So 4 minus x will always equal y x minus 3. Okay, now when you see a bracket, let's multiply this out. So 4 minus x would equal xy minus 3y. Okay, now it's very similar to the question before. Let's get all the x's on one side. We have two x terms over here. We have a minus x and we have an xy. Okay, so those are two over here. Let's just highlight that a bit more formally with a green box. So those are our x terms. These are our non-x terms over here. So let's get all the x's on one side so we can get this. Now in this case, I'm going to bring the x's on the right side, only because we're going to have positive x's when we do this. You see? So the minus x became a positive x over here, and this will make a positive 3y as well. You could take all the x's on one side, but we'll end up with all negatives and dividing by negatives, but it'll give the same answer. But this is a preferred method over here. So we have two x's now on one side. This is what we like. We want this, two x's on one side, you see, because it allows us to now factorize this. Let's factorize this. X outside, y plus 1. Leave 4 plus 3y over here. Therefore, 4 plus 3y all over y plus 1. And that's how simple this is. This has to be in the right order though for this to make sense. We can put a bracket in there. It doesn't make any harm. Okay, so look through that. Look how we used the idea of fractions, the first f, and factorize to get this answer over here. Here's section B on our toolkit on our revision card. So let's write down the subheading of fractions. The second F we're dealing with in this video, and this is all about putting an imaginary 1 underneath that number and cross multiplying your fractions. So pause this slide and write this key subheading down of fractions. Question 3b challenge. So press pause, make X a subject, and press play when you have done this. So this question looks a bit different from the ones we've dealt with before. Let's see how we can do this. So first of all, let's make x a subject over here. Now, you know that you should always try to get x by itself on the left hand side, no matter what. That's what we should be doing. So any x term, let's first of all make this a green little square, and also the non-x terms red and red. Okay, so there are three different terms. Let's try to get that green one on the left hand side. So we're going to do this. 1 over x equals 2 over z, take away 3 over y. Okay, so we simply move this to this side over here. Right, now let's try to get this to look like a method where we can use cross multiplication. So let's try to simplify the left hand side. Before we do that, let's just do the flipper. It helps us to understand this. 2 over z minus 3y over y equals 1 over x. Let's now try to get one number underneath here. To do that, I'm going to be doing this thing called camping method. If you remember this, step 1, step 2, step 3. Okay, that's when your denominators are different. So we have this zy, and on top we have 2y minus 3z. Okay, I won't go into detail how we got that, but you should be familiar with that. So that's what we do over here. Now we can use cross multiplication and say this 2y minus 3z times x equals 2y times 1. So basically we can say this 2y minus 3z, and the whole thing with x in front of it will equal 2y. Let's go over here. Let's multiply this out over here with the x. So we can have this 2xy minus 3xz equals 2y. Okay, stay with us over here. We like this. Why? Now we have x's in both of these. So in effect, we could factorize this with 2 x's on the left hand side. So we have x outside, 2y minus 3z equals 2y. And guess what? The next step, you can simply do x equals 2y all over whatever we have over here, which is going to be 2y minus 3z. I'll put it in brackets to make it look better. Okay, so go through those steps. There are quite a few steps, in fact, over there to do this. But the key thing was understanding this as a fraction type of context, okay? Because we wanted to make this look as a fraction, two fractions, should I say, to cross multiply that with a single denominator on each side, like over here and over here. That was the key point. So this is the end of our video for applying these techniques of factorizing the fractions, and we should be an expert now in advanced formulae, the 3 F's as your mnemonic. So you should be well acquainted with applying the technique of factorizing. Okay, when you see 2 x terms, you need to get them on one side and factorize this. Okay, if you see a fraction, you need to put an imaginary 1 underneath the whole number and cross multiply. All right, so these two things should be quite easy for you to look through right now. Our 3 steps for this you should have mastered. Any question will involve, first of all, identifying whether it needs factorizing, either 2 terms in x or fraction you can cross multiply. Once you've got that, you can simply rearrange it to make x a subject, and your result will be inevitable. So pause this, make sure you understand these 3 steps and what we've gone through. Let's just get a brief reminder of our toolkit when we turn over. So finally, let's add section C to our toolkit over here, and we will deal with the 3 F's. So factorizing, you've learned today, formulae, which is our topic obviously, and fractions. So factorizing and fractions give this topic real life, and these two techniques come up all the time in the exam questions. So the 3 F's we've summarized over here in section C. So write this down please in your toolkit. Question 1, let's do it. Press pause, make x a subject of this formula, and press play when you have finished this. Question 2, let's do it. Press pause, write this formula down, and make x a subject, and press play when you have done this. question 3, let's do it. Press pause, write this question down of this formula, and make X a subject. Press play when you have done this. Congratulations, you have now completed this video on Advanced Formulae. So that's really good. You should be able to make X a subject from any formula you see now and identify it with the obviously 3F formula, factorizing formulae, which is your actual topic, and fractions. Those 3Fs will always come up. So go to your revision planner right now and make sure you hit that feel good factor, that flow factor, on at least 8 out of 10 or above on this. If not, go back on this video and go through your revision notes. So well done once again.